All right, so now we're going to look at this part of our syllabus, 5.3, in use of the sine rule. So in the last lesson, we learned that area of a triangle, we can use this formula, half AB sine C, but that's equivalent to half BC sine A or half AC sine B, because I can always rename the angles of my triangle, move them around to fit. So let's look at how we can transform these to come up with the sine rule. So here's the sine rule. So if I start by looking at these first two equations and set them equal to each other, then I'm going to have half AB sine C is equal to half BC sine A. Well, I've got a half on both sides, so that cancels. I've got a b on both sides, so that cancels. If I divided both sides by b, it would cancel. So now that leaves me with a sine c equal to c sine a. So I'm going to divide both sides by this a and c. So divide by ac, divide by ac. And I'm going to do that because on both sides I'll get something that cancels. A cancels here, c cancels here. So this leaves me with sine c over c, capital C for angle, little c for side, is equal to sine A over A. So let's look at what we're talking about here. If I have a triangle, let's make it definitely scalene. All right, so let's label this A, B, C. Across from angle A is side little a, across from angle B is side little b, across from angle C is side little c. So what we're saying is that the ratio, the division of the sine of this angle divided by a side of this length is equal to sine of this angle divided by length of this size. I could have done this same process using these two equations. So if I had done that, let me just take this, shrink it down a little bit. All right, so let's repeat that process. I'm going to look at these two equations. So half BC sine A equals half AC sine B. Again, my halves cancel. This time I've got a c in common, so they're going to cancel. That leaves me with b sine A equal to a sine B. Now divide both sides by the sides, AB. And I picked those because those are the two that I see. So cancel, cancel. And now I'm left with the last of the sine rule relationships. Sine A over A equals sine B over B. So what this means is that I can really pick any part of my ratios or any parts of my triangles to match up. I'm always going to match up angle with the side across from it. So I'll match up an angle over here with the side across from it, or I'll match up an angle over here with the side across from it. So I can pick any of the things that I know to set up an equation that helps me find unknowns. Notice that with these equations, so let me write them out again. I've got sine A over A equals sine B over B equals sine C over C. So all of these ratios are going to be equal to each other. I can also take all of these and flip them over. So side over sine A, side B over sine of angle B, side C over sine of angle C. So if I don't know the angle, I want to use this version. Don't know the angle. If I don't know the side, I want to use this version. If we look up in our syllabus, They show us the side version, but the angle version with these on top is also true. In the next video, we're going to look at some examples of using the sine rule.